Hi, and welcome everyone to the latest emissions analytics webinar. I hope everyone can hear us okay. The topic of today's presentation will be tyre emissions from the latest electric vehicles. And before launching into a whole bunch of results, this is a very complex topic, and so the presentation will set out a conceptual approach first and then move on to results. I hope it'll prove interesting on a topic of rapidly growing interest, and welcome all your questions and feedback afterwards. In terms of the format, it's the same as usual. So I will present for about half an hour, and then there'll be up to half an hour for questions from anyone. And this will be the first part of a series, and we do welcome, even after the webinar, interactions with anyone on the call on this really important and growing topic. So please do put your questions either as we go or at the end into the chat box, and I'll attempt to tackle them later on. There is also, in case any of your colleagues are unable to join this morning, there will be another version of this webinar at 5 p.m. British Summer Time this afternoon, where I'll also take another set of live questions. So on that note, let's crack on. So the agenda of what I want to cover today will be, first of all, defining what tyre emissions are. It's actually, even that level is quite complex. Then look at what are the regulatory trends today, how we've approached it from an experimental point of view, and then looking specifically at the question of battery electric vehicles and what the trade-offs are being faced in the real world. Then segueing from there into what's our tyre emissions test program going forward, and then summary in terms of what is the state of knowledge today and what's the future work we need to do. So first of all, defining tyre emissions. In a sense, there's three broad elements of this. The first is in the manufacturing, and that's where a lot of the topic of activity is in the industry at the moment, essentially making the production of tyres more sustainable. And through the production process, through substituting alternative materials for the petroleum-derived components that are substantial contributor. The second part of it is in terms of the in-use phase, and that's where we want to focus today, and it'll look at the larger and smaller particles and also the VOCs off gassing from tyres. So that's where we'll do a deep dive today. There is a third part of it, which is the whole end of life question of tyres, and there are 2 billion tyres probably worldwide that come to the end of their life each year, and what we do with those is a real problem. They've historically been used as some combination of in rubber crumb soccer pitches, and also being burned in cement kilns and other industrial locations. None of these are ideal either from a pollutant point of view or a CO2 point of view, and therefore there are lots of initiatives around circular economy and repurposing tyres in less noxious ways, but that's still very much work in progress, and I won't even try and tackle that today, maybe a topic for another day. So looking at then specifically the in-use emissions, and the easiest place to start when doing this is to look at the mass emissions when a vehicle is being driven in real world or laboratory conditions. And that's because ultimately the approach to measurement here can be very simple in terms of weighing the tyre at the beginning and end of some representative driving cycle. And I'm putting up our results here just to show what results we've derived, but really it isn't the meat of what we wanted to go into today. But to put it up front, we've tested a range of different models of tyre on the same vehicle, all tested from new on the public highway in a mix of road situations with an average distance of around 5,000 kilometers each. And The graph shows you the mean and the distribution of the results we've got over these 18 different models of tyre from different brands. And the average value currently is running at 67 milligrams per kilometre. The range from the 25th to 75th percentile is between 46 and 77 milligrams per kilometre. But there are one or two outliers, quite particularly at the top end of that range. There's one significant outlier which remains unexplained because it wasn't some snow tyre or something unusual. It was a mainstream tyre. But this is helpful in terms of deciding what a limit value that could potentially be put on tyre wear. And if you wanted to restrict approximately, let's say, 20% of tyres currently in operation, that would suggest a limit value around 80 milligrams per kilometre. And by restricting that worst 20%, that would give a disproportionate, much bigger than 20% reduction in total tyre wear, assuming an equal sales proportion in the marketplace. So that's just the first sort of framing piece of information on the mass emissions side. But then this is where it starts getting more complicated. So the mass emissions is really, it's the easy bit, and it's only part of the environmental problem, because mass isn't the only metric to use. We also very much need to look at particle number as well. These tend to be produced under much more dynamic driving, cornering and braking particularly. And what we found from our testing is that about only 11% of the mass is from particles with lower than 2.5 microns in diameter. However, they account for almost 100% of the particles in terms of particle number emitted. So you've got this, in a sense, you've got a very large number of ultrafine particles and a smaller number of bigger particles, but which account for the vast majority of the mass. And this is in line with the literature, the academic literature as well. And the graphic I've taken and used top right is a good summary across about 15 different bits of research of the size, the modal diameter that people are seeing, and plenty of other researchers are also seeing down to around 10 nanometers in diameter. So I think it's fair to say that it's no longer controversial to say that tyres produce nanoparticles in quite significant number, and there is still debate as to the best way of measuring it and what exactly the values are, but that they do exist in significant number. And that sets up, therefore, tyres as an issue, not just for drainage off roadways, but for different distances of transmission and transport, such that it affects air, soil and water, depending on the particle size and the exact conditions. But then that's still not the end of the story by far, because there are also, tyres have the potential of creating what I've termed secondary pollutants, but actually it's both primary and secondary, in the sense of tyres are made of a lot of organic compounds, largely derived from crude oil, many of which are either volatile or semi-volatile. And so simply as a tyre is sitting there in the environment, it will be off-gassing VOCs. And some of these VOCs are bad for the health, combinations of problems for respiration through to cancer. And we'll talk a little bit more about that later on. So just sitting there doing nothing, they are emitting VOCs, and that can come from the tread and indeed the sidewall. And so the graphic I put up there is the chemical analysis of the tread, which is the blue part, and the sidewall, which is the orange part, which shows there's a lot of similarity in the highest concentration VOCs. There are some differences as well, but they contain significant amounts of these volatile and semi-volatile compounds, which are not great to be released into the environment. In a primary sense, for direct health impacts, if inhaled, but crucially then how they will interact in the atmosphere to create secondary particles. So that's the secondary organic aerosol yield that I talk about, SOA. And if you just take toluene, that has a yield of 4 times. So for every microgram emitted from the tyre, that can lead to 4 micrograms of particles through combination with other components in the air. And that's before we even get to the issue of ground level ozone and smog, and how these VOCs are a precursor for that as well. So you must think of tyres not just as a source of particles, but also a source of VOCs, and then look at those complex interactions. So that's why they're a problem and why they need so much study. In terms of the regulatory trends, well, from being nowhere on the regulatory agenda a few years ago, it's now shot up through different motivations. The primary motivation in the United States, as I'll come to, is through marine health of aquatic life. In Europe, it's been driven by electrification. So our move for decarbonisation to move to electric vehicles has led essentially to much heavier vehicles, and that has the potential to increase tyre wear, which I'm going to come on to in a minute. And so by including in Euro 7 a limit value on tyre emissions, it is trying to cover off that risk that it will just lead to it will swap decarbonisation for other environmental problems. So Euro 7 has the proposal, or at least a placeholder in the proposal for putting this limit value on new tyres. It's more sketchy, in my view, in terms of how this would work for the replacement tyre market. So when you go in, first and subsequent changes of your sets of tyres, the problem being people may not follow the same brands and go for some cheap and nasty tyres second time round. That needs to be fleshed out more. The test method is still not established, but the Task Force on Tyre Abrasion at UNECE is working on this frantically and making decent progress. Nevertheless, the earliest possible introduction of this would be 2025, much more likely 2026, 7, and it could even be 2028 and afterwards. It's all very much being actively debated at the moment, and nothing is yet approved. There are some conceptual issues that are having to be hammered out, one of which is whether more specialist tyres, for example, ice tyres, need to be included or should be excluded, because they, in a sense, they are there deliberately for extreme grip in difficult circumstances. But if you use them on asphalt, then if you use them on asphalt, then the wear rate is much higher. So there's a debate whether that needs to be included or not. But the bigger potential loophole is the discussion around whether one should regulate milligrams per kilometre of tyre wear emissions, or whether it should be divided then again by the vehicle mass. And in a sense, to normalise for the mass of the vehicle. And there are some good logical reasons for that. However, if that were entertained within the main regulation, the problem would simply be that it would incentivize even more heavier vehicles. You could argue it might give battery electric vehicles a free pass, and that would be a major problem. So in a sense, one has to link it to the mass of tyre emissions per unit of activity for light duty, not per unit of payload, even if that may apply and be very relevant for commercial vehicles carrying commercial payload. REACH has historically, and Euro 7 is not the only part of the European regulation. REACH, the chemical regulation, has for many years regulated 8 polycyclic aromatic hydrocarbons, and that's being expanded in terms of the number being covered. So in a sense, that was the earliest element of chemicals being regulated in tyres. In the United States, it's rather different. So the thing with the driving force here has been the west coast of the US and the mass die-off of the coho salmon, which was finally linked in 2019 to 6 ppd in tyres, forming 6 ppd quinone in the environment. And we've written about this in the newsletter that the link I put up there. And the California rule, which is literally just coming in now, forces manufacturers to investigate alternatives to 6 ppd. The reason it's not just banning it is because there is no viable alternative to 6 ppd really proven yet that is less toxic than 6 ppd. But the California rule is forcing R&D into that, or for the manufacturer to remove the tyres from sale in California. There's a very accelerated timeline on this, impressively accelerated timeline, which is just the initial submissions to the California EPA needs to be by November this year. So it's really pushing it along. The downside to flag is that this actually, as legislated today, is only a one-off exercise. So the tire manufacturers all have to investigate the alternatives, make their submissions, do what they then decide to do. But this isn't, there won't be every X years a similar review again. So it may be that there's no alternatives to 6ppd today, and we all carry on, but there might be one that comes along in a few years' time, and it would be interesting for California to look to make this a recurring assessment. The other West Coast states are similarly concerned by the 6ppd problem, but are taking or are forming other policy approaches which are potentially more prescriptive and more directional, but we're currently awaiting details on that. And the second part of the US regulation, they are tackling the question of replacement tires head on. And the basic idea here, which is in relatively advanced stages of development, is that tires sold in California need to be at least as energy efficient, so at least no more rolling resistance than the original tire on the vehicles. And this is light duty, including light duty pickup trucks. At the moment, as a matter of fact, the average rolling resistance for replacement tires is 21% greater than the original tires. So that's a really neat encapsulation of why, of the nature of the problem. The proposal is for a 5-star rating for these replacement tires, effectively done by manufacturers, but for use at point of sale and to inform consumers. Boundary condition here is that in not increasing rolling resistance, there mustn't be any negative effect on safety, durability, or chemicals in the tire which affect the end of life processes. Then there are limit values which are slated to come in. So the maximum rolling resistance coefficient is going to be capped at 9.0 from 2026, and then ratcheting down to 7.0 from 2028. So there is, from not much a few years ago, now a lot of activity in this area. So our experimental approach is as follows. So there are the 3 key bits to characterize tire emissions: is the wear rate, the chemical speciation of what's in those tires, and then how hazardous those compounds are. And that's the best way to get the overall environmental impact. And the component parts are, and I have shown this slide in some places before, but we have designed an on-road sampling mechanism, which is a universal fitment across all vehicles without modification to the vehicle, which articulates with the steering wheel, but in a way that's road safe and legal. And then the sampling mechanism can theoretically be coupled to any form of detector or collection receptacle. And it's a patent pending system. And it doesn't pretend to be able to collect all particles. It's not intending to do what the tire collector is intending to do, which is to collect as much as possible, but it is enabling sampling at representative locations in a very flexible way in real world conditions. Then the chemical fingerprinting side, that's where we can either take where sample collected on the road or chunks of original tread, and effectively, if it's original tread, as close to reverse engineer the chemical composition of the tire as possible using 2-dimensional gas chromatography and time of flight mass spectrometry and a multi-stage pyrolysis process that we developed and validated. And the uncertainties have been characterized by the National Physical Laboratory in London. And that this sort of approach can never be perfect in doing this. There will be certain compounds that break down under pyrolysis, but they break down in a predictable way that allows us to work backwards from the compounds that we do observe to what is likely to be in the tire. That said, most of the compounds through our method do not break down through this process. And the final bit of the 3-stage evaluation is to look at the hazards. And there's obviously a huge amount of academic work going on to expose tire particles to humans and animals and the like to come up with primary data, and we're part of many of those. But in the meantime, we've developed a hazard evaluation using the European Chemical Agency hazard codes submitted by manufacturers at the individual compound level. So they disclose when they're selling a product, what's in the products and their hazards. And so we've used that data, merged it with our data, put severity index against each compound, and then allows us to come up with a single value, either for a compound or then weighted up for a whole tyre, weighted by the concentration of that chemical in the tyre, so we can get to a single value for a tyre as well. Now, with there's obviously the question of dosage and exposure time, and so I do not pretend this to be the last word on toxicity. It's in a sense the first word on it. But we have done correlation exercises with other metrics for hazard, and we get a fairly close correlation between this and other measures. So we think it's a reasonable starting point. So that's the background, the regulation, and the test methods. So what does it say particularly about battery electric vehicles? And so what's the challenge? I mean, the challenge, some would say the allegation, is that the battery electric vehicles are on average heavier, and this extra weight combined with the extra torque, the almost instantaneous torque, low speeds particularly, of BEVs lead to higher tyre wear emissions. And it's particularly touchy subject because of recently the particles from the tailpipe have fallen dramatically due to not just putting on particle filters onto vehicles, but the increasing filtration efficiency of those filters over time. And we've shown in the newsletter, Gaining Traction, Losing Tread, which is on our website, that the ratio today on modern vehicles is almost 2,000 times more tyre wear mass emissions from the tyres, all four tyres on a vehicle, combined with the tailpipe. So that's why, from a regulatory point of view and priority, this is one of the reasons this is now shot up the agenda. And that's combined with then actual studies, partly done by us, but done by other people as well, which has looked at what is the effect on real world tyre emissions of this extra weight and torque. And we came up with figures, depending on the experiment, exactly between about 20 and 25% increase. But if Michelin, for example, have done their own completely separate study from us and came up, they quoted a figure of 20% publicly, and the research is actually 10% to 20%. But nevertheless, that's very much in the same ballpark as what we're saying. So that does look on the surface of it like BEVs do lead to higher tyre wear emissions. However, and this is where it starts getting somewhat complicated. What comparison you make really does matter. What is an equivalent pair of vehicles? Should you make it on the basis of the maximum payload of the vehicle, the empty weight, the power, the maximum speed, maybe the cost, or something else? Should you factor in regenerative braking or not? All BEVs have significant regenerative braking, but some ICE vehicles do and some don't, through particularly the mild hybrid systems, and obviously the full hybrids do have regenerative braking. Should you take into account any torque control features, of the various modes, driving modes that a vehicle has, which one should you choose? They can all make a material difference, and there's arguments on many sides as to what the right comparison should be. But then also the comparator tyres matter. Should you take the tyres as was on the vehicle when the manufacturer sold it new? Should you take it with the tyres brand new or after a few thousands of miles? There's many different factors which can affect the end answer. And also in making the comparison, this isn't just about mass emissions as well. What about if the BEV tyres were more toxic, then that they managed to reduce the wear but at greater toxicity? So what that comparison is matters, and it can lead to long and drawn out arguments. And I think the conclusion you have to come to is that chasing the perfect like-for-like comparison is impossible. we would justify the ways we did it, including in the article we did called Do No Harm, where we compared a Tesla Model Y to a Kia Niro hybrid, was as fair a possible comparison as you possibly can get. Because it isn't just about comparing on characteristics, specifications. It's also what real choices are consumers making in the marketplace. Because ultimately we're trying to reduce aggregate tyre emissions into the environment. But, you know, I no doubt I will continue to have arguments about this forever and ever. But let's set that aside for a moment and look at the trade-offs then. So even if we may not be able to come to an absolutely definitive conclusion, what are the trade-offs? And the one thing we can be certain of empirically of what's happening out there is the BEVs are heavier. That trend is clear at the moment in the marketplace, and that is correlating with having bigger tires, which means for every extra 100 kilograms of passenger car weight, and this is passenger cars only, empirically seems to lead on average to a increase in tire width of 4.8 millimeters, which is about 2%. And a 0.27 inch extra rim size, a 2% increase, very slightly lower profile tyres, and a 0.32 meters squared of extra surface area, which is about 4%, which leads to, we would see extra tyre emissions of about 2.2 milligrams per kilometre, so 3% on average increase, and a 2.8 microgram per minute extra off-gassing VOCs due to that greater surface area. So about a 4% increase. So heavier vehicles, higher load vehicles need bigger tires, and that's what it empirically looks like today. Now, that's not to say there may be some design breakthrough and whatever else that might change that empirically in the future, but that's what it looks like today. But the first surprising thing possibly is it appears, and this is based upon the information from the European tyre label that comes with these tyres, that these bigger tyres have better performance. Whether it is they can carry more load, they're actually engineered for higher speed. They're actually coming with slightly better rolling resistance and better grip. The only bit that they are slightly worse, and it is very slight to the point of being probably statistically insignificant, is the noise slightly worse. So they perform better. So that's actually a good thing. Now, they are definitely more expensive. So goodness comes at a price, which then leaves the question of, well, okay, so they're better performance. They may be bigger, but they're better performing. Are they more or less toxic? Because actually, I should say they are faster wearing in terms of mass and more off-gassing. So for an environmental point, through their bigger size and the loads, they are shedding more mass and more VOCs into the environment. But what about the toxicity part of it? Well, it turns out that it seems that through the clever engineering of the tyre industry, the toxicity potential, as measured on our normalized scale that I talked about, seems to be better. In fact, 4.3% lower potential toxicity. And this is driven, it appears, by significantly lower concentration of aromatic compounds. And those tend to be the ones, then not all carcinogenic, but that's where the carcinogenic ones tend to lurk, in the aromatics group. And actually the average is 9.5% lower aromatics concentration in a tyre. And if you look at the bottom right chart, that actually is the average and error bars of the variation by rim size across the bottom, and then the toxicity index up the right. And so you can see quite clearly visually that the mean does decline pretty smoothly across the increasing rim size, even if the variation within each of those classes is still significant, and that must be noted. So I then pulled out by some of the key biggest manufacturers what's the variability across all their range, and you can see that even within each manufacturer, depending on the size, shape, the performance characteristics desired, there's big variations within manufacturers as well. So yeah, it's important to show these mean trends, but we mustn't lose sight of the variability tyre to tyre as well, and that will be crucial from the regulation point of view. But nevertheless, we must put it out there that yes, these electric vehicle tyres and these vehicles may be heavier and wear more, but it looks like at the moment today, the tyre material is potentially less toxic. Finally, on these results, I focused on the European side. The US side is always rather different. We've done a similar analysis on US tyres, and there are many similarities. You know, the heavier duty the tyre, well, bigger the vehicle, the heavier duty of the tyre, the wider, the taller, the larger rims go along with that. And we're also seeing in the US that that goes along with less toxicity as well, due to even lower aromatics than in Europe, but offset by a greater proportion of alkanes, the alkene group. Overall, and as shown in this table, if you just look at our sample of the total market, it is US tyres are substantially less toxic than European tyres. Probably US tyres being sold for durability first and foremost, rather than rolling resistance and the performance characteristics of actually going around corners and the like, leads to simpler formulations which are less toxic. It would be interesting as the impact of the US regulations bites, what that trend will be, and that's one of the points of the ongoing studies we will be doing, is to track how that develops. So that's the data, what the data shows, and the interesting enigmatic position with BEV tyres. So what we're doing going forward is the following. So we've got an ongoing program of testing both the wear rates and the chemical composition, and we're going to be assessing in 7 dimensions as shown in this chart. So essentially there'll be a load index which represents obviously the load maximum load potential of the tyre, then against the sort of 3 classic performance criteria in terms of efficiency, grip, noise, and then the 3 pollutant criteria: the wear rate in mass per kilometre, the toxicity potential, and then the off-gassing component as well, which I haven't talked about and gone into detail today about that dimension. That will be for a future day, but that will be one of the 7 dimensions we're looking at. And closer to the origin, smaller values are better for the performance and the pollutant criteria. And this is real data that I put up here, which was from our Do No Harm report comparing the Tesla Y to the Kia Niro. The Hankook tyres were worse in all of the pollutant dimensions than on the Tesla Y, and were noisier, but had better rolling resistance, so more efficient. So we can see there in a very neat encapsulated way how those different trade-offs are expressed in new tyre formulations. Moving on to I don't know why there was a pause on that slide. Maybe it was a dramatic build-up to the results for 6ppd. So 6ppd, this is the results across all the tyres we've tested so far, and 6ppd has one of the honours of being a compound that has appeared in every single tyre we've tested so far. But the concentration varies hugely, and that's what this histogram shows. The blue bars show the distribution, or the frequency distribution by concentration bands of the 6ppd. And it does, as a pointer to regulators, it should be said that there are some today, even though they have 6ppd, it's very low concentrations. So why not incentivize everyone down to that low end? That might be a better route than trying to get rid of 6ppd completely and spend a lot of time and effort finding some alternative. But thinking of California as well, there are also substitutes beginning to appear in tyres. So one of them is IPPD, which we're seeing in about 10% of tyres, and is a substitute for 6ppd. And the orange bars are the concentration distribution that we're seeing today. Now, the problem with IPPD is it's not necessarily any less toxic than 6ppd. So yeah, it's a substitute, but is it a good substitute? So that's still very much work in progress in California. So in conclusion, when we stand back from all this, why are we bothering putting in such a large amount of effort into this relatively unglamorous area? It may be relatively unglamorous, but it is a very important environmental area, and I've described tyre emissions as omnipresent. We're probably looking at about 6 million tonnes of just wear material per year globally, which is roughly 4 kilos per car per year, so 8 pounds. That excludes completely the up to 2 billion end-of-life tyres per year, and we're trying to find something to do with those as well. Larger particles get released there into the drainage systems, largely of roads. Fine particles will be the ones typically settling by the roadside and within a short distance. Then you've got the ultrafine particles, which stay airborne potentially for a long time, and whose fate is still rather uncertain. But what it does show is there are multiple vectors for human inhalation or ingestion. And that's before we start talking about animals and fish. The most sobering of all through the research we've been doing was the research that came out of China, which studied the quantity of 6-ppd and 6-ppd quinone in adult urine. And the figure that they derived was 135 nanograms per day of these two chemicals together were being detected in human urine. So even though there are still lots of informational gaps and how actually these particles find their way is not fully understood yet, because 6-ppd doesn't really only primarily comes from tyres, we know the source and we know that it's passing through us and then going somewhere else. That is, if there's one thing to hang on to as to why we should be worried about this, that is it. So the key messages in summary is, I think it's fair to say tyre emissions is a more complex and significant problem than previously thought, and there's certainly no simplistic answers that battery electric vehicles have terrible, much worse tyres and that therefore they're evil and ICEs are good. No, all vehicles have tyre emissions. It definitely seems to be a function of weight. So BEVs having a weight problem is an issue, but there already seem to be some mitigating factors in toxicity that are in place. But be careful of averages, as always. The high variability within each class that we've looked at and within each manufacturer does matter, and is why regulation it does have a significant role. And the combination of tyre and the vehicle. We can't just look at tyres in the abstract. How they interact with the performance of the vehicle is very important. And so we need to look at not just new vehicles, but also regulating the replacement market. And if you put the worst tyres on a big heavy BEV, you're probably going to get to the worst possible outcome of all. But then we also need to be conscious of the economics of it as well. These BEV tyres, there's the good news potentially that they're less toxic, but they are much more expensive as well on average. So that's a justice distributional issue potentially as well. So I suppose in essence, we would say developing regulation must be holistic and empirically informed. I am worried to some extent with the European focus on the milligrams per kilometre, or even worse, milligrams per kilometre per tonne as the way forward. At least there needs to be a greater integration with the REACH side of it to make sure we don't clamp down on wear at the price of worse toxicity. But it is a worry rather than something borne out today. So what are we doing practically? Well, first of all, we wouldn't pretend to be able to do it all ourselves, and we're cooperating with a lot of people, and anyone on this call as well would be delighted to discuss and work together. What we did launch a few months ago was the Tyre Emissions Research Consortium, which is a complete open LinkedIn-based group, link shown there on the slide. And all you have to do is sign up to certain key principles which govern the membership that we're trying to get to the bottom of tyre emissions. I'm extremely pleased to say we've already got over 850 people signed up and many participating, and we are circulating information daily on the latest research and discussion around this. So please, if you're not already following that, please do follow it and participate. I think it's a really useful forum for exchanging information. Of course, we are developing our services, both testing services. So if you need tyre chemical analysed or wear studies done on the road, please come to us. We have a big database of all the chemical information from all the tyres we've ever tested, down to the individual compound level, identifying them, quantifying them, tracking them. That's a subscription database we'd be delighted to talk to you about. However deep for R&D or higher level benchmark tracking, it can be used for those multiple purposes. So please do get in touch on that. But we're very excited to announce today, for the first time actually, that we will be taking a further step in terms of activity in this area by launching 2 conferences that we'll organise next year on the specific subject of tyre emissions and sustainability. The first of which will be in Prague in February, and then a follow-up one in April in California, Southern California, which the aim is to bring together like-minded people looking to try and get to the bottom of this problem in the most effective way, and to network and to present the latest findings. So we're doing this, pre-sale is on now. It's not officially launched on our website yet, but please do express your interest at that email address there if it's something you might be interested to attend. And finally, we will also, so we do regular webinars. We will continue that series, releasing the more specific and ongoing results of our expanded independent EQUA test program. So where we are getting tyres and vehicles and testing them in the real world conditions, like we've done historically with tailpipe emissions. And these results will be released approximately monthly, focusing on the very latest products coming to market. So the latest eco, green, lovely, sustainable tyres. I'm going to find out, are they any better or not, and what's the interaction with the latest vehicles of ever-growing weight. And these, because this is very specialist and information, we are opening it to all current clients of emissions analytics and subscribers, plus academic students and accredited media. So if you're interested but not currently a client, there are very easy ways to get access to this. So please do get in touch with us, and we can offer you really cost-effective, flexible ways of getting access to these monthly webinars. So do drop me an email or to info@ or in the chat here. Very happy to talk to you about that. So thank you very much for listening. I hope that was a useful canter through this interesting topic. I know I've run slightly longer than my self-imposed timeline, but there we go. We've got 15 minutes for questions, so I will just pause for a moment and thank you for all your time. Please do put any further questions in the chat, and I will pick those up shortly. Thank you very much. So I'll try and tackle as many of these questions as I can in the time available. If I don't get to your question, please do pick up with me afterwards. So there's a question, even while stationary, is there a temperature dependency for emissions? So when the car is parked, for example, and the answer is absolutely. So just to give you, the way we've done this is an additional method alongside the pyrolysis. So the pyrolysis is designed to work out what's in the tyre, and which gives you an idea of the potential for those chemicals leaching out and off-gassing. But it's not actually an off-gassing experiment. We do, in parallel with that, we will do micro chamber analysis, where we put a small amount of that material into a chamber of known volume and heat it up to various temperatures to be able to look at the rate of off-gassing of different volatilities of chemical over time. So to answer that's the way we're able to answer that question. Yes, it is very much temperature dependent. It's not quite as straightforward as some sort of linear or exponential relationship, because different things comes off at different temperatures. As you can imagine, even at the lower temperatures, the most volatile things off gas first, but you need to get up to higher temperatures before you start getting some of the more semi-volatile. And that is then interesting when you compare that with the size distribution of the particles. So if you brake hard or corner hard, the surface temperature of the tire will rise, which will affect not just the size distribution and the total mass as well. It will also affect the proportion of different chemicals of different volatilities that come off. It's simpler than just having a car sitting there in different ambient temperatures diurnally. Will have a similar dynamic profile as well. So we've been able to study that by these controlled experiments at different temperature levels. So I think that's to Stefan, to your question. So yes, micro chamber approach is the main way we're doing it. We are also doing some shed tests as well, but as you rightly point out, that would then be confused by if an ICE vehicle, evaporating fuel, etc., and the various plastics. We're actually using the shed test more for that very measurement of what is coming off the other materials, in particular plastics on the vehicle, for both the environmental and a vehicle interior air quality point of view. So that's our primary reason for using sheds, not the subject of today's webinar, of course. For tyres, it's been much better to take it into a micro chamber situation to understand that without the confusion of other things. What about the VOC from asphalt? I mean, absolutely right. There will be VOC from asphalt. It's not something we've measured in huge detail as yet. But by doing our micro chamber method as well, that means that at least the results we're looking at are not confused by any interference from the asphalt. Road wear generally is a problem for the measuring the particles, the number and the mass, and the biggest single challenge for our sampling mechanism is the interference from road wear and resuspension, and also to some extent exhaust particles from other vehicles. And that is probably the single biggest challenge of all of these things, is how to actually measure real world tire particles without the interference from the other sources. What's the difference between low profile and higher profile tires? All modern vehicles seem to be moving to large diameter, low profile tires. Well, in fact, the last phrase there is the key one. It's really rather impossible to answer the question about the effect of the profile of the tires themselves. And it seems from the data that the profile itself doesn't make any difference. But in reality, lower profile is correlating with wider tires, with higher speed ratings, with higher load ratings. And so that's the results we've seen today, that they seem to be higher wearing but less toxic. So I guess the profile is the most visible bit of visually defining in the way we see those tires, but one has to see that as it's a bundle of characteristics designed to convey a heavy vehicle in a safe way. What emissions are expected when using 100% natural rubber tire? Well, it would be, if it was literally 100% natural rubber, you would have it would totally transform and reduce, and if there were no additives as well, eliminate most of the problem compounds that we're seeing. There's obviously a cost question there. There's also a performance question there. And the reason that synthetic rubber is used is for a wide range of performance requirements. So, but nevertheless, what I observed is that one of the hypotheses for why the heavy duty tires and the bigger, higher load light duty tires are less toxic is because of higher proportion of natural rubber. So that their lower emitting characteristics, I think we're seeing the benefit. We can't be absolutely conclusive about that yet, but we think that's one of the main reasons that they are looking less toxic. Is the number of hazard codes the correct weighting? H300 substances should be weighted higher. Yeah, good point. But and yes, we actually do that. So there is a severity index. So according to a judgment on how bad, how hazardous, or what level of hazard that hazard code reflects, is related in a severity index that we do apply. So something that's sort of mildly irritating to fish will be at the low end of the rating, and something which is highly carcinogenic to humans would be at the top end of the rating. Yes, I just simply doing an average of it wouldn't be satisfactory. Is the toxicity rating based on VOCs or pyrolysis? So the toxicity rating in the presentation today, the main bulk of what I've shown has been based on the pyrolysis. So it's trying to get to what is in the tyre, and so essentially a leaching potential. So as those tyres abrade and those particles sit in the environment, it's trying to see what's the ultimate source. You could also use the same toxicity methodology to assess the off-gas VOCs as well. That would be perfectly conceptually robust. And we do that. It's just not been in the presentation today. What about nanoparticles from BEVs? So, well, very good question. Highly variable between BEVs, I think, is probably the safest thing to say right now. It is, well, the nanoparticles are in large proportion created under more extreme driving events, so particularly braking, sharp cornering, to some extent acceleration, when the surface area of the tyre is hot as well. To the extent that that correlates with what happens with BEVs, so if you drive in ludicrous mode, other extreme driving modes are available. If you drive in ludicrous mode, then I think it's reasonably certain to say almost whichever type of tyre you're running with, you will get a higher proportion of nanoparticles than if you drive in a non-ludicrous mode. Even then, I'm being tentative because there are many variables at play there. And you can mitigate this by your choice of tyre as well. So I don't want to give a absolutely blanket BEVs have higher nanoparticles conclusion. I probably would go as far as saying, because of the extra weight and torque, it has more nanoparticle potential if driven in a certain way than a fairly svelte internal combustion engine. Will we distribute our easier question here? Thank you. Will we distribute these slides? Yes, absolutely. We will post them on our website after this. The recording of this will also be available as well. And but if you can't get access to it, just drop me an email. Okay, is the reduced toxicity seen on BEV tyres intentional or just a coincidence of design and the production process choices? Extremely good question, and our suspicion is it's a combination of the two. Putting more natural rubber in it, in these tyres, is probably more of a design, where it's a choice to give the performance requirements necessary, rather than as a mitigation of other more nasty synthetic additives that have been added. So I suspect that is to give, just like there's a higher proportion of natural rubber in truck tyres, more natural rubber is probably being put in these BEV tyres, and that has a concomitant reduction in the toxicity. But there will be other changes and other additives being put in which will weigh against that, and I think that is the explanation of why we see a big variability. The exact recipe matters, but if one thing I understand about the tyre industry, it's intentionality. These things are not done by accident. These are done at very sophisticated design decisions. But nevertheless, it may well be in this case that by using the greater natural rubber, it has brought a reduction in toxicity. So that might be just one of those, you know, lucky or useful associations. But the honest answer is we don't know for certain. We are trying to infer it by analysing the data. Would love contributions from the tyre industry experts who would be able to give us more confidence in those conclusions. Okay, we're coming to an end, but I've probably got time for a couple more. What limits would you include for a Euro tyre standard, and would this apply to all new tyres? Well, I think it has to apply to not just all new tyres, but well, including the replacement market, if that's what you mean by new tyres. Yes, I think it really has to, because the real danger is people put cheap and nasty tyres on a BEV when they come to the first change. So I think that has to be included from the get-go. What limits would I include? I think you have to hand in hand target the wear rate and the toxicity as a point of principle in an integrated way. And sort of Europe's still there, getting halfway there in a piecemeal fashion, I would say. The US is adding the, and it mustn't have a negative effect on the other criteria as well. American market is particularly sensitive to durability. So it is a complex area, and the danger is you make too complex a regulation. However, I think if you just look at wear, and particularly the standard must be in milligrams per kilometre for light duty, not milligrams per kilometre per tonne. That would be a major mistake. Okay, I think I'm going to wrap up here. I'm going to take one more. I think, Sig, I think I've sort of covered off your question about nanoparticles from BEVs and answered as diplomatically as I can. What is the efficiency index? That's essentially rolling resistance, the rolling resistance coefficient expressed as an index. Okay, I'm going to tackle the last. How do tyre emissions contribute to air pollution, and what can be done to mitigate their environmental impact? Well, I think we can now, because of the nanoparticle components, I think we can be confident of that there are nanoparticles in significant number being released to the air. And possibly with very long transport distances, even though we're not certain of that right now. Then you've got the VOC off-gassing, so you've got, for people in close proximity to tyres, you've got direct inhalation of VOCs, some of which are nasty, and then you've got the contribution to secondary organic aerosol formation, so that's a secondary addition to particles, and the contribution to smog as well. If we look at the various emissions inventories, whether it is MFAC in California or the European inventories, COPA, whatever it is, I think they all systematically underestimate this effect. I think they are overestimating the contribution to air pollution from modern internal combustion engines, and they're underestimating. So overestimating from modern internal combustion engine exhaust pipes, and underestimating from tyre emissions from vehicles of all ages. They are not underestimating anymore the tailpipe emissions from older internal combustion engines. That remains still a big problem for air quality, but it's not the modern internal combustion engines. It's now the tyres from vehicles of all generations that probably is getting close to the single biggest source, is our calculations. So I hope you found that useful and interesting. I see we've got lots of questions come in, so I will crack straight into them. Please do keep them coming as well in the chat box below. The first one said, you mentioned that California is restricting the use of tyres containing 6 ppd, but it's a single investigation. What do you think will happen if the tyre makers fail to find a suitable replacement for 6 ppd in the next 2 years? Well, that is definitely a possible outcome. There is nothing in this regulation that forces an alternative to be found. It could be that the tyre manufacturers submit reports which say that it doesn't exist. They carry on selling the tyres, and if there is no repeat of this scrutiny process after the 5 years, then it could effectively be the status quo ante continues. In reality, there is growing focus on this area. The plight of the various marine species, because it's not just coho salmon, it's also various species of trout as well, and others now. The pressure is likely to grow, if anything. So even though there's no guarantee of a repeat or expansion of the Californian process, I think in reality there will be, although we just don't know what the form is at the moment. And David, you also asked that we're now saying that that there's 6 ppd in every tyre we've tested, and previously we thought we'd found one that did not. It's a very fair question. Essentially, what we did after the first few tests, we were able to develop our test method to make it even more sensitive. To put it in context, this kit can measure down to at least the ppb levels, but we made the process by some improvements more sensitive, and found that even in that one tyre there was a low concentration of 6 ppd, and we then kept that method constant throughout. But actually the main message out of that is that there are some tyres with very low concentrations of 6 ppd in them, and that points to, I think, as I mentioned, a relatively easy solution. If some people can reduce the concentration, why can't everyone, in simple terms? There's a question of clarification about the 67 milligrams per kilometre, whether it's per vehicle or per tyre. It's per vehicle, so 4 tyres in total. And as a rule, when we quote wear figures, because it's relating to the tyre as installed on a vehicle rather than in some sort of abstract notion, that we always quote on a per vehicle basis. What was the size range of particles included in the emission rate? Well, in that 67, it's effectively the whole particle range, because it is measured by mass loss, by weighing the tyres at the beginning and end. So everything's included. If we were talking about the sampling device, the range we would normally be testing for with a typical detector would be around 10 nanometers up to 10 microns. Question about typically a tyre must be broken in for at least 1,000 miles before you can start to get wear data, because the tyre undergoes a set. Well, did we take this into account? Well, yes, we did take it into account, and we have done actually some long-term studies over about 20,000 miles, where we can see the behavior in the early days, in the midlife, and then towards the end of the life of the tyre, and effectively see the declining wear rate over the life of the tyre. So yes, we are mindful of that, but I think our position on the first 1,000 miles is, even if the tyre is setting, then it is still abrading. So the rate of wear in that first 1,000 miles is a relevant piece of information to know, even if it isn't representative of the average lifetime wear rate. Moving on, what is your view on how the tyre industry is communicating around this issue, both in terms of factual descriptions of the particles and in terms of potential damage to the environment? A very good question, and it is somewhat controversial. I think there is definitely a change of tune going on generally. And also, as background, I would say that the tyre industry's approach to this and their knowledge, particularly amongst the major players, is extremely sophisticated and very knowledgeable internally, but not much is shared externally. Representative bodies have been rather more oriented to playing down these issues historically, and emphasizing the knowledge gaps rather than exhibiting a desire to fill them. But that, I think, has changed, and the research on the coho salmon really was the moment where the sands really did start to shift, and now I think there is a much greater realization this problem is only going to get more high profile. It's only going to get worse, if anything, with heavier vehicles, and there is a much more openness and desire to understand and hopefully collectively to fill these knowledge gaps. So that's a positive change of sentiment and direction, I would say. What does the latest research say about the hazard to human health of these particles? I I mean, it is one of those areas where the more you look, the more you find, and the more you study. And previously, no one was really looking at ultrafine particles from tyres. So when you accept that they do exist, and then you start doing experiments as to their ingestion, inhalation, and how they get into the bloodstream and deeper, then you start beginning to understand the potential human hazards. So it's moving from a point of knowledge gaps to knowledge, where we're trying to help fill some of the gaps as well by doing specific experiments on human lung cells, even in vivo experiments, because while we can see that a lot exist, it doesn't necessarily mean that they are more hazardous to human health. We are making, people are making some projections, estimates, and on good reason, and carrying over knowledge from other sectors and from tailpipe emissions. But that doesn't guarantee anything, given the complex and almost unique nature of these particles. So I think I would say the concern is growing, but there's still many gaps to fill before we can start saying things definitively. And interesting, that's what drives rather a wedge between the European approach and the US approach, where the Europeans will generally content to act on a precautionary principle based on sufficient evidence, whereas the US require a much higher burden of proof before doing anything too nuclear. David, you've also asked the experience of, the car industry around diesel tailpipe emissions and how the tyre industry is communicating. Does that compare to how, whether there's a parallel between the two? I think probably fair to say lessons have been learned, and the total denial by the vehicle industry of any issue at all prior to Dieselgate, and then a complete loss of all reputation because of it, or trust because of Dieselgate, has been a wake-up call and a salutary example of what can happen. And I think that message has been taken on board. I mean, this is a more complicated area because tyres don't stand on their own. They're only affecting the environment as installed on a vehicle and used, primarily, the off-gassing aside. So it is slightly more complicated in where responsibility of this should be spread and would lie. But nevertheless, I think, Dieselgate the memory of Dieselgate will fade slowly in terms of what happens if it goes wrong. I see there were some questions I think answered about what SOA meant. Yes, and it's secondary organic aerosol. So where these gaseous compounds will react with other things in the air to form solid particles, so which are not there originally from the tyre, but form chemically. Sam, you've asked the question: how does our sampling system compare to other methods? Well, there's a number of methods that have been developed. Michelin has developed a method, Ricardo has, and others. So we have compared the results to ours. So ours is a hub-mounted system which pivots with the tyre. Ricardo's method similarly does pivot by anchoring to the suspension arm. Other methods secure to the body of the vehicle immediately behind the tyre. That one does have issues in terms of the distance from the surface of the tyre to the inlet, and that it doesn't pivot with the front wheel, which really restricts its use meaningfully to the rear tyre, in our view. And I suppose the honest answer of the state is that the results are quite strong artifacts of the sampling setup at the moment, and even within one organization set up where exactly you put the probe relative to the tyre in the ground. So this is ongoing work by many of us to work out how can you standardize, characterize that sampling system in a way that you can actually get meaningful and useful results from it. Do we expect legislation in any part of the world that would require tyre makers to list ingredients to provide data on the materials that go into the tyre? Well, in a sense, the 6 ppd one is sort of what that for one compound. Am I seeing something that would require complete disclosure of an ingredients list in a similar way to a foodstuff? No. And that would be tricky from protecting commercial value and genuine competitiveness. But could there be disclosure of more crucial ingredients? Yes, and in fact, under REACH in Europe, with the 8 growing to, I think it is 22 compounds, in effect, that's forcing disclosure around a certain list. So I think it will happen, not on a complete basis, but maybe on a growing breadth. Your sampling method will also collect particles that did not originate from the tyre. Do you know how much this is? So this is an extremely good question and goes to the heart of the problem. So we will pick up resuspended material, road wear and brake wear in different proportions at different points, depending on the dynamics of the vehicle and the road surface. The most satisfactory way to separate that out at the moment is through post-test chemical analysis to effectively separate out material that's been collected and being able to apportion it to the most likely source. Because tyres are an open system, it is very hard, I should say, to be able to do it by some sampling mechanical means at the point of collection. It possibly can be minimized by various means of location or type of sampling inlet, but I think always there will be, quote, contamination that needs separating post-test. Question about toxicity, and I put this in inverted commas. What about Korean and Chinese cheapies? Have you tested basic chemistry? We've done the full organics profiling that's described, and I think while there are some, quote, Chinese cheapies there are also some sophisticated formulations that are coming from Asian manufacturers, particularly Koreans, that are becoming more sophisticated in their formulations compared to the established operators. That's one of the things you would see in our subscription database, where we show that in effectively league tables of toxicity and aromatics proportions between different tyres aggregated by nationalities or companies. So it's not simple, but yes, we've done it. Yes, we can see it, and actually some of them are beginning to give the established Western companies a bit of a run for their money. Okay, I'm going to tackle one last question in the time we've got. So if ultrafine particles make up the majority of tyre emissions, are there plans to quantify particle emissions by number instead of mass? They make up the majority of tyre emissions by number, not by mass. So it's still the bigger particles that make up the vast majority of the total mass, sort of almost definitionally. I suppose what we're saying is there are a lot of ultrafine particles there. Measuring that number of particles, that's particularly where we're working on optimizing the sample collection. Those are the difficult ones to measure, to the point I don't think there's any basis of doing it at the moment that could be standardized and regulated. So there are lots of ways to quantify it, and there are lots of people doing it, but still very much work in progress. It definitely is not a case where you could regulate on the basis of number or even do a labeling based on number. But it's something that is very relevant from an environmental point of view, and we need to continue working in that direction. So I've run out of time. It is on the hour. I can see that there are some questions I haven't been able to answer, which I will attempt to try and pick up following this. But please do ping those emails directly to me at nick@emissionsanalytics.com. Equally, if you have an interest in our database, attending our conference and the future releases of WEAR results, particularly on the growing area of battery electric vehicles, then I'd be very happy. I will certainly respond to you. So on that note, thank you very much for your time. Appreciate it. I know how busy everyone is, but to spend the time is greatly appreciated, and hopefully see you on the next webinar. Thank you very much.